Hi, in this video, I'll be going through the 0971/21 paper. So this paper is for students taking the extended syllabus. So let's get started. Okay, so in the first question, which two gases will diffuse at the same rate at the same temperature? So in other words, right, if you want gases to diffuse at the same rate at the same temperature, then they must have the same density, and in other words, they must have the same molecular mass or relative molecular mass. So in other words, for this question, they are asking us to calculate MR. Okay, and the answer will be the option where you have both the molecules having the same MR. So let's take a look at A. So A, we have carbon monoxide CO and carbon dioxide CO2. So if you have to look at carbon monoxide, it has one carbon, one oxygen. Carbon dioxide has one carbon but two oxygen. So no way they will have the same molecular mass because CO2 has one more oxygen than CO. Next, let's look at carbon monoxide and nitrogen. So carbon monoxide is CO, nitrogen is M2. So to find the relative molecular mass, we will need to look at your periodic table. So let's go to the periodic table. Okay, so now we are back at the periodic table. So let's find the MR of CO. So to find the MR of CO, we'll take a look at carbon and oxygen. And because we are interested in the relative molecular mass, so therefore, we will be looking at the relative mass of carbon and oxygen, which is this bigger number here. Okay, so for carbon, its relative atomic mass is 12. For oxygen, it is 16. So the MR of CO is 28. How about for nitrogen? The MR of nitrogen, okay, so nitrogen contains 2 nitrogen atoms per molecule. So the MR of nitrogen is 2 times 14, which gives us 28. So in other words, CO and N2 has the same molecular mass. And if they have the same molecular mass, what can we say? Well, they will diffuse at the same rate. So going back to our question again. Okay, so we know that CO and N2 have the same molecular mass, so they'll diffuse at the same rate. So the answer for this is B. Next, let's move on to question 2. Question 2 is a question that you will see also in paper 1. So it was also tested in the core syllabus. Okay. So now let's look at it. A student measures the time taken for 2 grams of magnesium to dissolve in 50 cm³ of dilute sulfuric acid. So which apparatus is essential to complete the experiment? So because the student is interested in time, he or she will need a stopwatch. And the student needs 2 grams of magnesium. To measure 2 grams, which is mass, you need a balance. Next, he or she also needs to measure 50 cm³ of dilute sulfuric acid. So to measure volume, you'll need a measuring cylinder. So the apparatus needed will be stopwatch, measuring cylinder, and balance 1, 2, and 4. Okay, which is A. Okay, so the answer for 2 is A. Moving on to 3, the number of protons and neutrons and the electronic structures of 4 particles W, X, Y, Z are shown. Which particles have the same chemical properties? So in order to have the same chemical properties, they will need to have the same number of electrons. Or they need to be not same number of electrons. Their atoms need to have the same number of electrons, or in other words, they must be the same element. Okay, so if you want to have same chemical property, it must be the same element. So element depends on the number of protons. Okay, so the one with the same number of protons will have the similar properties. So now let's take a look at this. So we have W, X, and Y. Z, we know that it is a different element, so it's out. So we have W, X, and Y. But if you look at the options here, what do you notice? You only have 2, right? So let's take a look in greater detail. So neutrons will not affect chemical properties. It only affects physical properties, so we can ignore looking at this column here. Next, let's take a look at electronic structure. So we look at it and we notice that W, X, and Y. So W has a different electronic structure from X and Y. Okay, reason is because if you look at this, W has 10 electrons. Okay, so this means that it is an ion, okay, with a charge of 2-. Whereas for these two, they are basically still atoms because they have 8 electrons, which is the same number of electrons as the number of protons. Okay, so in other words, right, they have not lost or gained any electrons, they exist as atoms. So in other words, because X and Y exist as atoms, while W exists as an ion, the atoms and the ions will have different properties. So therefore, those with the same properties will be X and Y. So the answer option is C. Next, let's take a look at question 4. Which substance should be pure for its intended use? So basically, this is just memorization. So if you need something to be very pure, it must be something that is consumed or for very specific purpose, like in semiconductors and so on. So a drug for curing disease is definitely needed to be very pure, because if there is any impurities or contamination, it might cause it might not be suitable for the person to take. Okay, limestone is not pure for the iron extraction. Petroleum is in fact a mixture already. Okay, after you separate them in fractional distillation, the petroleum that you get is also not pure. It is a range of different hydrocarbons. Water for washing a car. So the water that you have has a lot of dissolved material. It need not be very pure. Okay, because it's just for washing a car. So in other words, the one that needs to be pure is a drug for curing diseases. Moving on to question 5. Metals and ionic compounds have similarities and differences in their structure and properties. Which rule about metals and ionic compounds is correct? So this question is a question on your metals, okay, and ionic compounds. So you need to compare them. So what are the similarities between metals and ionic compounds? So what is a metal made of? A metal is made up of positive ions in a sea of electrons. Ionic compounds are made up of positive and negative ions. So similarity, they both contain positive ions. That's true, so A and B are correct. Both are malleable, not true. Only metals are malleable, ionic compounds are not. Next, let's take a look at the difference. So only ionic compounds contains anions. That is true, okay, because metals do not contain anions, they contain negative electrons. So because metals, it is positive ions in a sea of electrons. Let me use E minus to represent. So positive electrons in a sea, positive ions in a sea of electrons. That is metal. Okay, they do not contain any anions. Whereas for ionic compounds, they contain both the positive ions and the negative ions. Okay, so only ionic compounds contains an ion. That is true. Okay, ionic compounds do not contain a sea of electrons. Okay, so therefore, the one that is correct for both the similarity and differences is A. So the answer for 5 is A. Which diagram represents the outer electronic arrangement of nitrogen molecules? So we know that for nitrogen, okay, if you look at the periodic table here, okay, so let me flip to the periodic table. So if you look at nitrogen, it has 7 valence electrons. So if it has 7 valence electrons, what does it suggest? Well, it means that it has 2 electrons in the first shell and 5 electrons in the second shell. That is for its atom. Okay, remember, if you're looking at the electronic structure, you always look at this number here, which is the atomic number, because the atomic number tells you the number of protons, which is equals to the number of electrons in the atom. All right, so always look at the smaller number if you're interested in electrons. Now, let's go back to the question. Okay, so now let's look at this question here. So which diagram represents the outer shell arrangement in nitrogen? So we know that for nitrogen atom, its electronic configuration is 2, 5. Okay, so now there are 5 valence electrons. So in order to achieve stable octet configuration, it needs 3 more electrons. So how does it get 3 more electrons? Well, it will share 3 electrons. So each end will share 3 electrons. So if I represent the electrons of this with a dot, it will also share 3. Okay, so this will be the electronic or the dot and cross diagram for N2, showing the outermost shell. So there will be 6 electrons here. Okay, so 6 electrons are being shared. Okay, and then there are a pair of electrons here, or 2 electrons for each nitrogen that are not shared. So in this way, each of the N will have a stable octet configuration. Okay, so just remember, if you have 5 valence electrons, right, in order to achieve octet configuration, you need to get 3 more. So how to get 3 more? You share 3 and you get 3. All right? So the answer for this is D. Okay, going on to question 7, the equation for the reaction between barium chloride and dilute sulfuric acid is shown. So which row shows the state symbols for this equation? So in order to know the state symbols, you need to refer to your solubility table. So barium chloride itself is aqueous because all chlorides are soluble except for your lead and silver. So barium is considered soluble. Sulfuric acids are soluble, so it's definitely AQ. Then barium sulfate, so all sulfates are insoluble. Okay, all sulfates are soluble except for barium. Okay, and lead, zinc is slightly soluble. So in other words, this one is a solid. And HCl is hydrochloric acid. Acids are all soluble in water. So you should have AQ, AQS, AQ, which is A. So basically for this question, you just need to remember your solubility table. Okay, moving on to 8. The relative atomic mass AR of an element is determined by comparing the mass of one atom of the element with the mass of one atom of element Q. So what is Q? So basically this one is definition. So basically to find the relative atomic mass, you need to compare the mass of one atom of this element with 1/12 the mass of one atom of carbon-12. So the answer is A, which is carbon. Next, question 9. The equation for the reaction between aqueous lead-2 nitrate and aqueous sodium chloride is shown. If 100 cm³ of aqueous lead-2 nitrate of this concentration, 0.1 mol per dm³ is reacted with an excess of aqueous sodium chloride, which mass of lead-2 chloride is obtained? So in other words, right, for this question, we know that because this sodium chloride is in excess, so lead-2 nitrate is the limiting reagent. So how much products is found is dependent on the limiting reagent. So we will start off by finding the number of moles of lead-2 nitrate. So to find the number of moles given volume and concentration, you take volume times concentration to find the number of moles. So we will find volume of lead-2 nitrate, okay, which is equals to, remember cm³, we must convert it to dm³, okay, by dividing by 1,000, because this concentration term is in mole per dm³. So 100 over 1,000 is basically 0.1. Then you need to multiply by another 0.1, which is the concentration, and you get 0.01 moles. What am I writing? Okay, sorry. Let me do this again. So we want to find the number of moles of lead-2 nitrate. So number of moles of lead-2 nitrate will be equals to the volume multiplied by the concentration. So the volume must be in dm³. So we'll take 0.1 dm³ multiplied by 0.1 mole per dm³, which gives us 0.01. So the number of moles of lead-2 nitrate is 0.01. Okay, next let's take a look at this equation because we are interested in lead-2 chloride. Okay, so the mole ratio of lead-2 nitrate to lead-2 chloride is 1:1. So therefore, if there's 0.01 mole of lead-2 nitrate used, there will be 0.01 moles of lead-2 chloride formed. So the number of moles of lead-2 chloride formed will be 0.01. Next, we need to find what is the mass. So to find the mass, you will take the number of moles times the molecular mass, or the molar mass. So how do we find the molecular mass? Well, we will refer to the periodic table again. So I'll go to the periodic table now. So we are interested in lead-2 chloride. So lead is here. So it's 207. So I'm interested in MR of lead-2 chloride. So here is 207. Then I need 2 Cl. So I need to take 2 times 35.5. So let me type everything into the calculator. So I have 207 plus 35.5 times 2. It will give me 278. Okay, so now going back to our question. Okay. Okay, So I know that the MR is 278. So I will take the number of moles, which is 0.01 times 278, which will give me 2.78 gram. So the answer for this question 9 here is C. So the mass of lead 2 chloride obtained is 2.78 grams. Next, let's move on to this question here. So this is a question on electrochemistry or electrolysis. So the diagram here shows the electrolysis of concentrated hydrochloric acid and concentrated aqueous sodium chloride using carbon electrodes. Okay, so now let's take a look at this. Okay, so now at which electrode is hydrogen produced? So they are asking where will you have hydrogen. So let's take a look at this. So let's first take a look at this setup here. So I've concentrated hydrochloric acid. So the ions that I have will be H plus, Cl minus, and because there is water here, so from partial ionization of water, I also get H plus as well as OH minus. So these are the ions present. Okay, so now the positively charged, because I'm interested in hydrogen being produced. Okay, so hydrogen will be formed if H plus is being discharged, and H plus being positively charged is attracted to the negative electrode. Okay, so if you take a look at this setup, the only cation here is H plus, so the only thing that can be discharged at electrode 2 for this setup here is hydrogen, so it's H2. So I know that electrode 2 will have hydrogen gas being produced. Okay, so I know that the answer is either C or D already. So next, let's take a look here. So now, this setup I'm using concentrated aqueous sodium chloride. So sodium chloride, it contains Na plus and Cl minus. At the same time, because there is aqueous, so you have water as well. So you also have H plus and Cl minus. Okay, Cl minus is repeated, so let me erase it. So I have H plus. Okay, so now that I am here, okay, I know that I'm interested in hydrogen being produced. So in other words, right, I need to look at this portion here. Okay, and I also need to look at electrode 4 here, because the negatively charged electrode will attract the positive cations. So now that I'm done with this, the next thing I need to look at is Na plus and H plus. So if recall in your reactivity table, okay, hydrogen is below sodium in the reactivity series, right? So in other words, hydrogen will be preferentially discharged compared to sodium. So therefore, hydrogen gas will be produced instead of sodium. So with that, we will have H2 gas being evolved here. Okay, and because H2 gas is being evolved here, so the answer will be electrode 2 and electrode 4, which is D. Okay, moving on to question 11. Aqueous copper 2 sulfate is electrolyzed using copper electrodes. What is the ionic half equation for the reaction at the cathode? So let's take a look. You have copper 2 sulfate is electrolyzed using copper electrodes. So let's first start off by looking at the ions present in aqueous copper 2 sulfate. So in aqueous copper 2 sulfate, we have Cu2 plus, SO4 2 minus, as well as from partial ionization of water, so you have H plus and OH minus. Okay, next, we are going to use copper electrodes for the electrolysis. In other words, right, the the anode, okay, will undergo oxidation. So the copper electrode, being a reactive electrode, will be oxidized to form Cu2 plus. So this is at the anode. Okay, then at the cathode, where you have the cations, so none of this will be discharged because you have this reaction. Okay, the reactive electrode being dissolving into the solution at the anode. Next, let's take a look at the cathode. So at the cathode, okay, which is what we are interested in this question, either Cu2 plus or H plus will be discharged. So which one will be discharged? Well, this depends on the reactivity series. So recall that Cu is below H in the reactivity series, and therefore this Cu2 plus will be converted to copper, okay, at the cathode. So the equation will be Cu2 plus, okay, plus 2E minus from Cu. So the answer for 11 is B. Question 12. Which rules identifies a chemical change and a physical change? So a chemical change is one that is a change in the chemical composition. For physical change, there is no change in the chemical composition. Basically, there's a physical change, like a change in state, a change in color, and so on, but the components or the chemical components remain the same. So examples of physical change would be your state change, okay? So melting, boiling, freezing, evaporation, sublimation, all these are considered physical change. Okay, chemical change, it changes the component. So for boiling, it is, so let's take a look at the answer option. So for boiling, it is a physical change. It is not a chemical change, so A is out. Burning is a chemical change because your ethanol is now converted into carbon dioxide and hydrogen. So no longer do you have ethanol, you have CO2 and H2O. So this is a chemical change. So this is out. Okay, next, burning ethanol, yes, burning. So let's look at B. So burning ethanol is a chemical change. Evaporation, which is from a liquid to a gas, so it's a physical change. So B is the answer. Okay, so if you take a look at the rest, dissolving is also a physical change because you still have ethanol and water. It's just that they are now mixed with each other, so it's not a chemical change, it is a physical change. Burning is all combustions are chemical change, so this is out. Evaporation, okay, it's a physical change because it's just a change in state, so it's dissolving ethanol in water. So the answer is B. Now let's move on to question 13. So in question 13, you are given the equation for the reaction between hydrogen gas and gaseous ion. Between gaseous hydrogen and gaseous iodine to form gaseous hydrogen iodide is shown. The reaction is exothermic. So if the reaction is exothermic, we know quite a number of things, right? We know that the bonds formed are stronger than the bonds broken. We know that H2 and I2 are at a higher energy level than HI. We know that the temperature increases because it's an exothermic reaction and energy is given out. So let's take a look at this statement and see which statement explains why the reaction is exothermic. So A, energy is released when HH and II bonds are broken. This is wrong because bond breaking is endothermic. Energy is absorbed. B, the bond energies of the reactants are larger than the bond energies of the product. This is also wrong because for an exothermic reaction, the bond energies of the products are larger than the bond energies of the reactants. Okay. Next, C, the products are at a higher energy level than the reactants. No, the products are at a lower energy level than the reactants. Okay, so that your energy can be given out. Okay, so this is wrong. Next, D, more energy is released when two HI bonds are formed than when HH and II bonds are broken. This is true. So because it is exothermic, that means you actually release more energy during bond forming than the energy you use during bond breaking. Okay, so that you have enough energy to give out. Okay, because you release more energy, okay, than you need, okay, for breaking the bonds. So therefore the answer is D. Question 14, acidified silver nitrate is added to a test tube containing chloride ions. The test tube is then left in direct sunlight. Which row shows the observations and explain what happens to the reaction? So when you add silver nitrate to chloride ions, you have a white precipitate that is being formed. So it is either C or D. Okay, so now we are left with either C or D. So next, if you leave it in the sunlight, so when you leave it in sunlight, what happens is your silver chloride will become silver. Okay, so because it goes from silver ions to silver. Okay, this is a reduction process. If you compare it in terms of oxidation state of Ag decreases from +1 in the ion or Ag plus to 0 in the atom. So this is a reduction reaction. So the answer is D. So how do you know that it turns into silver? Well, this is in your syllabus. When you add silver chloride, okay, you leave silver chloride in the sun for some time, so it will basically get reduced to form silver. Okay, if you want your silver chloride to dissolve, you will need to add excess aqueous ammonia to dissolve it. Okay, question 15. So let's move on to question 15. Water is added to anhydrous copper 2 sulfate. What happens during the reaction? So if you add water to anhydrous copper 2 sulfate, then copper 2 sulfate will absorb the water and it will turn blue. Okay, and then we also know that this reaction is an exothermic one, so the solution gets hotter. So the answer is B. Moving on to question 16, you have aqueous iron 3 chloride FeCl3 reacts with potassium iodide Ki. So which statement are correct? So in the balance equation v, w, x, and y have the same value. So before we can answer these, we first need to balance this equation. So I have fe and fe, so 1 and 1, okay, fair enough. So let's assume that they are just 1, okay. Then let's look at CL. I have 3 CL here, 2 CL and 1 CL here, correct? So I have 3 CL altogether. Next, K is 1K and 1K here, alright. 1 I, but there are 2 I's here. No. So in other words, I know that I cannot have 1 is to 1 is to 1 is to 1. That doesn't work, okay? So now, if you are to take a look at this, let's still start off by I, balancing I. So there are 2 iodine here. So to balance, very likely I need 2 here. So once I have 2Ki, I have 2K. So in order to have 2Ks, what do I need here? So to have 2K, I will need Y to be 2. Okay, so now that I've changed this, I'll change CL, right? So now I have 4, 2 plus 2, which is 4 CL, right? Okay, but I only have like, how many here? Well, I only have 3, right? So let me try by putting 2 here first. So total I have 6 CL here. So if I were to also put 2 here, I have 4 plus 2, which is 6. Okay. So let's try this. So let's take a look. So now that I've put in these values here, let's look at whether we have the same number for each atom. So 2 Fe on the reactant side, 2 Fe on the product side. Great. 6 Cl on the reactant side. 2 plus 2, 2 times 2 is 4. 4 plus 2 is 6. So 6 Cl on the product side. Great. 2K on the reactant side. 2K on the product side. Great. Okay. 2I on the reactant side. 2I on the product side. So yes, so in other words, V, W, X, and Y are all 2, and therefore they have the same value. This is correct. Next, let's look at this. Potassium iodide is an oxidizing agent. So if something is an oxidizing agent, that means it oxidizes something and it is itself reduced. Okay, so let's take a look at Ki. Okay, and so K remains as this Ki here. The K is K plus. It still remains as K plus, so nothing happens to it. So let's take a look at I. So you have I minus here, and it forms I2 here. So in other words, potassium iodide is actually being oxidized because the oxidation stage increases from -1 in Ki to 0 in I2. So from -1 to 0, okay, in oxidation state is an increase in oxidation state, and therefore it is being oxidized. So if it's being oxidized, it's a reducing agent. So 2 is wrong. Next, a dark brown solution is produced in the reaction. So in order to find out about this, we need to take a look at all these colors here. So FeCl3, it is basically yellow, okay, or brown. Okay, next, Ki is colorless. FeCl2 is green, pale green. Okay, then this one is colorless, and this one is brown. Okay, so if you have a brown plus a green, okay, you will have a dark brown solution. So the answer is actually 1 and 3, which is B. Next, which statement about acids is correct? A strong acid has a higher pH than a weak acid of the same concentration. No, if you have a stronger acid, the more acidic it is, the lower the pH. Next, a strong acid is a proton acceptor. No, an acid is a proton donor. A weak acid is a proton donor. Yes, all acids are proton donor. That is why they are acids. So if it's not a proton donor, then it's not an acid. Because of the word acid, so therefore it's a proton donor. Okay, a weak acid is fully ionized in aqueous solution. No, the reason why it's weak is because it is partially ionized in aqueous solution. So the answer for 17 is C. Okay, let's move on to question 18. We have the oxides of two elements X and Y, and they are separately dissolved in water, and the pH of each is tested. So X has a pH of 1, so it's acidic. Y has a pH of 13 when dissolved in water. That means it is a basic oxide. So basically, this question is asking about acidic and basic oxides. So acidic oxides are usually formed from basically non-metallic oxides. Okay, So we know that X is an acidic oxide and Y is a basic oxide. So the answer option is either A or B. We can eliminate C and D now. Next, we know that an acidic oxide is formed from a non-metallic oxide. So X is non-metallic and a basic oxide is a metallic oxide. So Y is metal. So in other words, the answer is B. Next, question 19. An acid is neutralized by adding an excess of insoluble solute base. A soluble salt is formed. So what is the pure salt? How is the pure salt obtained from the reaction mixture? So in other words, right, this method of salt preparation is adding excess insoluble base or carbonate or metal, if the metal can react with the acid, okay, to an acid, okay, to form the salt which is soluble plus water. Okay, and because we add excess insoluble base, okay, we need to filter it out. So the first step is the filtration. Okay, so it's either C or D. So after you filter, now you have the pure salt solution as the filtrate. So your salt plus water is now in the filtrate and your excess base is in the filter paper as the residue. Okay, so now you have the pure salt solution. What you need to do is you need to evaporate some of the water so as to obtain a saturated solution. Then you need to cool it so that your crystals will appear. So the answer for 19 is D. Next, let's take a look at 20. The electronic configuration of Z is 281. Which statement about Z are correct? So 281, okay, so it has one valence electron, so it's in group 1, so it is a metal. It only has one outer shell electron, so this is out. It is in period 3. Let's look at the number of shells filled with electrons. 3 shells filled with electrons, so therefore it is in period 3, correct. So the answer for 20 is 1 and 3, which is C. Okay, moving on to question 21. The elements of group 4 of the periodic tables are shown. So these are the elements in group 4. What does not occur in group 4 as it descends? Okay, so the proton number increases. Okay, definitely the number of protons increases as you go down the group. The elements become more metallic. That is true. Carbon is a non-metal. Lead, tin, germanium, they are metals. So they become more metallic, which is correct. The electrons have more electrons in their outer shell. This is wrong. Because they are in group 4, they will always have 4 valence electrons, or the 4 electrons in their outer shell. Doesn't matter where they are. Okay, whether you are high up in the periodic table or low down in the periodic table, as long as you are in group 4, you have 4 valence electrons. So C is the answer. Okay. The elements have more electron shells, so they have more shells of electrons filled with electrons as you go down the group. This is also true. So the answer is C. Okay, question 22. Element M forms both M plus and M2 plus ions. So which part of the periodic table is M placed? So if it can exhibit variable oxidation state, very likely it is a transition method, because group 1 generally forms ions with a charge of +1. Group 2 forms ions with a charge of +2. Group 3 forms ions with a charge of +3. Okay, transition elements, variable oxidation state, so they can have different oxidation state. Like for example, copper can form copper ions, which is Cu plus as well as Cu2 plus. Iron can form Fe2 plus, Fe3 plus, and so on. Moving on to question 23. In the extraction of aluminium by electrolysis, cryolite is added to the bauxite ore. Which row describes the role of cryolite and gives the ionic half equation at the cathode? Okay, so basically this one is to know the electrolysis process for the extraction of aluminium from its ore. Okay, so now let's take a look. What's the role of cryolite? So we add cryolite, okay, so that it acts as an impurity to lower the melting point of your ore. Okay, because for the electrolysis of aluminium oxide to obtain aluminium, you're going to electrolyze molten aluminium oxide, so you need to melt it. Okay, so to melt it, temperature is extremely high. Okay, it's going to be very costly if you need to heat it so high to melt it, so we add impurities to lower the melting point. So the so it's either C or D now. So next, ionic half equation at the cathode. So at the cathode, aluminium is formed and from the ion. So in other words, it is this. Okay, so because you only have one aluminium ion here, you only form one aluminium. So Al forms Al. Okay, then charge must be balanced. So plus 3 minus 3 equals to 0. So the charge here is 0. The net charge here must also be 0. So Al doesn't have any charge. So this is correct. This is wrong. So because this is 3 plus, then minus 3. So the net charge is 0 on the reactant side. So it's the net charge on the product side. But there's only one Al here. But now there are 3 Al. So this is out. Okay. So you need your atomic balance as well as charge balance when you are balancing the equation. Okay. Now let's go on to 24. So 24 is on mouse steel. So mouse steel is galvanized to prevent corrosion of the ion. So basically you just coat it with a less reactive metal. So which statement about galvanizing is correct? Okay. So so you coat it with another metal. Okay, so like zinc. So galvanizing, you coat it with zinc. So which statement about galvanizing are correct? Galvanizing prevents corrosion because the zinc forms an alloy, nothing to do with an alloy. So if you want to protect something from corrosion, two ways. Okay, you either prevent, okay, so if you want to protect iron from corrosion or rusting, two ways. One way is to coat it with something that is non-reactive or waterproof so that it will protect the iron that is hidden beneath it. All right, so one of it is to coat it completely with something that is non-reactive or waterproof. So this layer here acts like just a waterproof layer to protect the iron from oxygen and water so that it doesn't rust. So examples of this method will be coating it with maybe a less reactive metal such as tin, painting it, and so on. Okay, another method is sacrificial protection. So you have iron here and you put a more reactive metal such as magnesiums or zinc and so on. So what these more reactive metal does is, because they are more reactive, when the water as well as the oxygen comes close, okay, they will react instead of iron because they are more reactive. So because they react, they will protect iron from reacting, so iron doesn't rust. So this is called sacrificial protection. So in galvanizing, we always use zinc for galvanizing. So in other words, the zinc acts as a sacrificial metal and corrodes in preference to iron. So this is correct. Okay, it forms an alloy, nothing. Forming an alloy only makes something stronger, but it has nothing to do with galvanizing. Galvanizing, you don't form an alloy, you just coat it above it. Okay. Next, if the coating is damaged, the water and oxygen do not corrode the iron. This is true. Okay, because even if the coating of zinc is damaged, okay, zinc is still more reactive, so it will still react in place of iron as long as there's still zinc left. But if you are using this method where you use a non-reactive metal or a waterproof layer, okay, to protect it, once you scratch any part of it, okay, the iron will start to rust because there's nothing more reactive to react in place of it. Okay. So for sacrificial protection, you do not need to cover the entire portion to protect the iron. But for when you're using a non-reactive metal, a metal that's not so reactive, or a waterproof layer or painting, once you scratch that coating, you expose the iron, it start to rust. All right. So the answer for 24 is 2 and 3. Next, which diagram represents the arrangement of the outer shell electrons of a noble gas? Okay, so remember, for noble gas, except for helium, which is in the first period, which has 2 valence electrons, the rest must have 8. Okay, this one has 4, so it's out. 1, 2, 3, 4, 5, 6, also out. 1, 2, 3, 4, 5, 6, 7, also out. So it is A, because A is helium, is in the first period. At most, it can have 2 electrons only. Okay, moving on to question 26. Which statement about the general properties of metals are correct? So this question is testing you on the properties of metals. So metals are good conductors of heat and electricity. True, because the electrons, the sea of electrons can move about to conduct the heat and electricity. They have low melting points, not necessarily true. Okay. They react with dilute acids to form salt and water. No, they react with dilute acids to form salt and hydrogen. Okay, so this is out. They react with oxygen to form basic oxides. Yes, in general, that is true because they are asking for general properties, so we don't look at the exceptions. So in other words, 1 and 4 are correct. So the answer is B. Next, reactions of 3 metals and their oxides are shown. So what is the order of reactivity of these metals from most reactive to least reactive? So if you add dilute acid, the one that is the most reactive will react with acid. Next, this one is a reduction reaction where you heat the metal oxide with carbon. The less reactive the metal, the more readily this reaction takes place. So we know that the one that reacts with acid but does not undergo reduction is the most reactive. So 2 is the most reactive. Next, the one, okay, that reacts with acids and also with metal oxide is the next more reactive one. And finally, if it doesn't react with hydrochloric acid, it's below hydrogen in the reactivity series. Okay, so it's the least reactive. So it's 2, 1, 3. So the answer is C. Moving on to question 23. So you have 3 metal compounds J, K, and L. They are heated using a Bunsen burner. These are the results. So which row identifies J, K, and L? So you have a colorless gas produced which relights a glowing splint. So when you heat J, you have a colorless gas which relights a glowing splint. In other words, you have an O2. So when do you have oxygen being produced? That is when you heat a nitrate. Okay, so you need to heat a nitrate. So we know that J is a nitrate. So A and B are out. So it's either C or D. Next, when you heat K, you have a colorless gas produced which turns lime water milky. So this is carbon dioxide. So if you heat a gas, heat a solid and it produces carbon dioxide gas, it is a carbonate. So it's so let's take a look at C and D. You have magnesium carbonate and potassium carbonate. So something about carbonates, group 1 carbonates, okay, do not undergo this decomposition reaction, okay, because they are stable. So in other words, potassium carbonate will not undergo this reaction to produce CO2. Only magnesium carbonate will. Okay, so the one that has no reaction is potassium carbonate because it's stable to heat. Group 1 carbonates are stable to heat. You can heat them for as long as you like. You won't get CO2. So therefore, L, when you heat it, which is L, which is potassium carbonate, okay, when you heat it, you do not get CO2 gas. So the answer for 28 is C. Now moving on to 29, the diagram shows the use and treatment of treatment process of muddy river water. So for the muddy river water, you need to make it into clear river water. Okay, then after that you disinfect it, okay, and then you can use it. So what's the use of the muddy river water? Well, you will never drink muddy river water. You'll use it for watering crops. So it's either C or D. So we have eliminated A and B. So next, use 2, you have disinfected the water because you want to drink. Okay, now let's take a look at process 1. So it goes from muddy to clean. So basically the process is called filtration. You remove the mud, the stones, and all the solid particles. Okay, after that, you need to disinfect it. So to disinfect it, you add chlorine because chlorine kills germs. Okay, so so this process 2 is chlorination. So the answer for 29 is D. Question 30. Question 30 is on the Haber process. The equation for the manufacture of ammonia in the Haber process is shown. The forward reaction is exothermic, so you know that here is exothermic. So in other words, the backward reaction is endothermic. Oops. Okay, so the backward reaction is endothermic. Okay, next, which row describes the effect of a stated change on the reaction rate and the U of ammonia? Okay, so if you are looking at the change in the reaction rate, right? So just remember what will affect rate of reaction. Well, it is the temperature, okay, then the size of the solid reactants or the catalyst. Okay, then you also have the pressure, increasing the pressure for gases. Okay, increasing the concentration for solutions, but there is no solutions here. Everything is gaseous state. So cannot increase the concentration of solutions. Then you also can add a catalyst to increase the rate of reaction. So these 5 things. Okay, so we know that in order to increase the rate for these reactions, there are 4 things you can do. Add a catalyst, increase the temperature, increase the pressure. Okay, and then if the solid catalyst, you divide it into fine pieces. Okay, increase the surface area of the solid catalyst. Okay, so now they didn't talk about the catalyst, so very likely we don't need to look at the catalyst. We do not need to look at the surface area of the catalyst. So we just look at the pressure and the temperature. So in order, so if I decrease the pressure, when the pressure is decreased, the rate of reaction will decrease. Okay, so this is out already. A is out. If I decrease the temperature, the rate of reaction will decrease. This is correct. Increase pressure, rate of reaction increase, correct. Increase temperature, rate of reaction increase, correct. So B, C, and D are possible answers after checking the first and second column. So now let's move on to the third column, effect on the yield of ammonia. So if you have to take a look at this, right, it is 4 moles of gas forms 2 moles of gas. So in other words, right, to push the reaction to the right to produce more ammonia, it will prefer to have a higher pressure, right? Okay, because this reaction will decrease the number of moles of gas and therefore decrease the pressure of the system. So therefore, you want a high pressure, okay, to push this reaction to the right. So because the number of moles of gases decreases with the reaction, okay, so therefore this reaction prefers a high pressure, okay, so, or the following reaction prefers a high pressure, okay, to counteract this decrease in pressure during the reaction. So if you have a high pressure, you will increase the yield. So when pressure increases, it increases the yield. So this is wrong already. So now let's take a look at temperature. So now this is an exothermic reaction. So to produce more ammonia, you will prefer a lower temperature. So decreasing the temperature will increase the yield. Increasing the temperature will decrease the yield. So if you look at it at the end of the day, the one with all the correct answers will be B. So 30 is B. Moving on to 31, fertilizers are used to provide 3 elements needed for plant growth, and the 3 elements are nitrogen, potassium, and phosphorus. So which 2 compounds would give a fertilizer containing all these 3 elements? So we need to look for an option that contains both N, K, and P. So for option A, you have N, and that's all. You do not have K, you do not have P, so it's out. For option B, you have N and P, you do not have K, so it's out. For option C, you have K and N, but no P, so it's also out. For option D, you have N, K, as well as P. So the answer for 31 is D. Question 32. The flowchart shows part of the process for the manufacturing of sulfuric acid and its electrolysis. Okay, so you have gas 2 and gas 1 from gas 3, then you get concentrated sulfuric acid, then dilute sulfuric acid, then get electrolyzed to get back gas 2. Okay, so basically for this reaction, this question here, right, you need to understand the manufacture of sulfuric acid in detail. Okay, so in order to manufacture sulfuric acid, what are the 2 gases that we start off with? Well, the 2 gases that we start off with are your sulfur dioxide and oxygen, right? Because you're going to burn sulfur dioxide and oxygen, okay, to form sulfur trioxide. Okay, so you know that 1 and 2, one of it is SO2, the other one is O2. Okay, so the one with SO3 or sulfur trioxide is out. So you're left with either A, O. So this is also out because there's no hydrogen. So the answer is just B without further checking, right? Okay, because you know it's SO2 plus O2 as one of these 2 gas. Okay, and gas 3 is sulfur trioxide. Okay, so the answer is B. Moving on to question 33, which statement about sulfur dioxide are correct? Okay, so sulfur dioxide decolorized acidified potassium manganate, yes, because it is converted to SO3, so it's being oxidized, and potassium manganate is being reduced, so it decolorizes. So this is correct. Sulfur dioxide forms when acids react with carbonates? No, when acids react with carbonate, you get carbon dioxide. So this is wrong. Sulfur dioxide can be used as a bleach. Yes, this is correct. Sulfur dioxide is used to treat acidic soil. No, sulfur dioxide being an acidic gas will make acidic soil even more acidic. So the answer option is 1 and 3, which is A. Question 34. What are the products when limestone, which is calcium carbonate, is heated strongly? So if you heat calcium carbonate strongly, you get calcium oxide and carbon dioxide. Okay, so which is calcium oxide and carbon dioxide. So the answer is C. Question 35. So it's organic chemistry now. The structure of the ester W is shown. Which row gives the name of the ester W and the carboxylic acid and alcohol from which it is made from? So whenever you have a question on ester, always look from the ester group, okay, and then divide it this way. So I found the COO here, so I'm going to divide it here, and I know this comes from the alcohol, and this portion here comes from the acid. Okay, so to name the alcohol, the esters, you will first start off with the alcohol. So this alcohol has 1 carbon only, so it is methyl. This acid has 2 carbons, so it's ethanoate. So the name of this ester is methyl ethanoate. So it's either C or D. Next, it is formed from this acid which has 2 carbons, so it is ethanoic acid. It's drawn from this alcohol with just 1 carbon, so it is methanol. Okay, so if you are interested in how to do this in detail, I do have a course on this. I'll provide it in the link in the description below. Okay, moving on to question 36. Ethanol is made industrially by the fermentation of glucose or by the catalytic addition of steam to ethene. So which statement describes an advantage of fermentation compared to catalytic addition? Okay, so ethanol is the only product of fermentation. No, this is definitely wrong, because the ethanol that is produced in fermentation is very diluted. It has a large amount of water in it, so it is not the only product. Okay, there are also other products that is formed during fermentation, like carbon dioxide. So this is not the only product. Next, fermentation uses a batch process, but catalytic addition is continuous. It doesn't tells us why it is an advantage, although this could be true. Okay, next, fermentation uses a higher temperature than catalytic addition. This is definitely wrong. Fermentation, it must be at a temperature lower than 40 degrees Celsius because you're using yeast. But catalytic addition, you're going to heat it to high temperatures above 170 degrees Celsius. So this is not true. Fermentation uses a renewable resource, and yes, and that is why it is advantage, because the glucose you can obtain from natural sources like maybe sugarcane and so on. Okay, now let's go on to question 37. Some properties of colorless liquid L are listed. So it boils at 65 degrees Celsius, so definitely okay, it is not water. Okay, anyway, there's no water as an option. Next, when added to water, 2 layers are formed which do not mix. So in other words, it is insoluble in water. So ethanol is out, ethanoic acid is out, because both of them are soluble in water. So this is insoluble in water. It does not react with sodium carbonate. So in other words, it's not acidic. So ethanoic acid is out. Next, it has no effect on bromine water. So if you have no effect on bromine water, that means it is not an alkene. So in other words, it cannot be hexene, because hexene will decolorize bromine water. So the answer for 37 is B. Moving on to 38, a molecule of compound P contains 2 carbons and 4 hydrogens. So it is C2H4. So which row represents P? So we know that it is C2H4. C2H4 is ethene. So we know it's either B or D. Okay, and we also know that it reacts with bromine, because alkenes react with bromine. So let's calculate the MR. So we know that the AR of carbon is 12 and the AR of hydrogen is 1 from the periodic table. So to find the MR of C2H4, we will take 2 times 12 because there are 2 carbons, plus 4 times 1 because there are 4 hydrogens. So this gives us 28. So the answer will be C. Moving on to question 39, the reaction of ethanol with acidified potassium manganate 7 is shown. So ethanol forms ethanoic acid, and this is an oxidation reaction because the number of oxygen has increased, the number of hydrogen has decreased. Or you can look at it as this is an oxidizing agent, so it will oxidize ethanol to form ethanoic acid. So in other words, this reaction is basically an oxidation reaction. Okay, last question, which polymer is a synthetic polyamide? So there are two things, one of it is synthetic, one of it is amide. So protein is out because protein is not synthetic, it is natural, it occurs natural. Synthetic is man-made. So protein is out. Next, we need an amide, polyamide. We know that polyethylene is an addition polymer, there's no amide bonds. Okay, and amide bond is this, CONH. Okay, so the answer is nylon because nylon has this amide linkage. Terylene doesn't, it has an ester linkage. Okay, so both nylon and terylene are synthetic, but terylene is a polyester, nylon is a polyamide. So the answer for 40 is A.